Hey everyone, and welcome. Today, we're going to dive into one of the most famous, and let's be real, maybe one of the most infamous algorithms in all of computer science, bubble sort. Let's get right into why it has such a dramatic reputation.
Look, let's just be honest, bubble sort gets a really bad rap. If you spend any time at all around programming, you've probably heard that it's slow, it's inefficient, and that you should never, ever use it in your real-world code. And you know what? All of that is pretty much true. So that begs the question, right? If it's really so terrible, why is this the algorithm that kicks off so many programming journeys? Well, there are some very good reasons. And by the end of this, I promise you'll see exactly why this bad algorithm is actually so fundamental.
To really appreciate its value, we first have to understand how it works. And you know, the real beauty of bubble sort is that it takes this big, complex idea of sorting and boils it all down to one single, super simple, repeatable move. So here's the textbook definition. It's a comparison-based algorithm. Really, all that means is that it sorts a list just by comparing items to each other. But the key phrase here, the part you really need to remember, is adjacent elements are repeatedly compared and swapped. That's it. That's the entire engine of bubble sort. Seriously, it all comes down to this simple two-step dance. You look at two items sitting right next to each other, you ask one question, is the one on the left bigger than the one on the right? If the answer is yes, you swap them. If not, you just leave them alone and move on. That's the whole thing. It's kind of like when you sort a hand of playing cards. You instinctively compare two cards at a time. This is that exact same logic. Okay, so doing that little swap just once doesn't really sort much of anything. The real magic happens when we repeat this simple move over and over again in what we call a pass. Let's actually see what that looks like.
All right, here's our messy, unsorted array. We're going to start at the very beginning with our first pair of numbers, 5 and 1. So is 5 greater than 1? Yep. So they're in the wrong order. We make our first swap. And just like that, the larger number has already started its journey over to the right.
So now our array has changed a bit. We just slide our focus one spot to the right and look at the new pair, 5 and 4. And again, the bigger number is on the left. So what do? We swap them. You can see the 5 is continuing its march down the line.
You're probably seeing the pattern here, right? That number 5 is on the move. Our next pair is 5 and 2. Once again, 5 is greater, so we swap. It's like the larger numbers are literally bubbling up to the end of the list.
Now pay attention here because what happens on this slide, or rather, what doesn't happen is really important. We look at our last pair for this pass, 5 and 8. Is 5 greater than 8? Nope, it's not. They're already in the right order compared to each other, so we do nothing. We just leave them alone and move on.
And with that, our first pass is complete. Now, take a good look at that array. The single biggest element in the entire list, the number 8, has made its way to its correct final position at the very end. That's the one thing that is absolutely guaranteed after one full pass.
But, okay, clearly the job isn't done. The rest of the array is still a total mess. So what do we do now? Do we just start all over again from the beginning?
Pretty much. We do the whole thing again, we start another pass from the beginning. But here's the clever part. We already know that 8 is in the right place. We don't need to touch it ever again. So with each new pass we make, the part of the array we actually have to worry about gets a little bit smaller.
So here's how the whole thing transforms. After pass 1, you can see the 8 is locked in place. Then, in pass 2, we do it all again on the numbers that are left, and the next largest number, 5, bubbles up to its spot. By the end of pass 3, look at that! The entire array is sorted. Each pass just systematically puts the next largest number right where it's supposed to go.
Seeing it happen with numbers on a screen is one thing, but how does a computer actually pull this off? Let's translate this exact visual logic into some simple Java code.
This right here, this is the heart of it all. That simple compare and swap move we were just doing by hand, this is what it looks like in code. It's just an if statement that checks if the element at some position j is bigger than the one right next to it at j+1. And if it is, we run the code to swap them. This one little if statement is doing all the heavy lifting for every single comparison.
But how do we get the computer to do that comparison over and over again? Well, we use loops. Think of it like this. The inner loop is the worker. Its job is to make one full pass down the line, comparing and swapping. The outer loop is the manager. It tells the worker, hey, great job on that pass, now do it all again, but you can stop one step earlier this time. Together, these two nested loops guarantee we make just enough passes to sort the whole thing.
Which brings us all the way back to our original question. We've seen it work, and we know it's not the fastest. So why on earth is this algorithm so important to learn?
And here is the real answer. Bubble Sort's true value was never about its speed. It's all about its simplicity. The logic is so straightforward you can actually visualize the entire process in your head, and that makes it an incredibly powerful foundational concept. Once you've really wrestled with these nested loops and swaps, more advanced algorithms like quicksort suddenly become so much easier to understand. It's the perfect educational tool because it forces you to master the absolute fundamentals: loops, comparisons, and moving data around. It's not the best sorting algorithm, but it just might be the best teaching algorithm.
So now that you've seen how it works visually and how it translates to code, the absolute best way to make this knowledge stick is to just do it yourself. So here's your challenge. Open up your favorite code editor and try to write bubble sort completely from scratch. Don't worry if it's not perfect the first time, just give it a shot. And once you've got it working, you can explore other similar algorithms like insertion sort or selection sort and start to see all the different ways there are to solve the same problem.
For so many people, finally understanding bubble sort is that first big aha moment where the logic of programming just clicks. So I'll leave you with this question. What was your first programming aha moment? What was that one concept that made it all fall into place for you? Let us know, and thanks for exploring this amazing piece of code with us today.